Now we're on to the DEB mock papers pre-leaving Cert 2020, and we're on to paper 1 now, question 2, which is a sequence and series question. It says that the first term of an arithmetic sequence is 12 and the sum of the first 9 terms is 135. So the sum of the first 9 terms, we know we're talking about a series. It wants us to find D, the common difference. These are the formulas we'll be using. We look at these formulas here and we can see what do they require. Then you require a first term and a common difference. So let's see what we have. We have the first term given to us in the question. It says it's 12. And it also tells us that the first 9 terms added together is 135. So we can say S of 9 is equal to 135. Now, using this formula here, we can say something like this. That S of 9 is equal to 9 over 2, because I've replaced the n now by 9, times 2a, which is the first term, which is 12, plus n minus 1, remember we've replaced the n by 9, d, which is what we're looking for. We know if we do all that, we should get an answer of 135. Okay, so let's look at this. Let's leave 9 over 2 at the front. 2 times 12 is 24. 9 minus 1 is 8, so that's 8 times d equals to 135. Now what I do here is just multiply across everything by 2. Like, it's an equation. What we do to one side, we do to the other. We're okay here, right? As long as it's multiplying by a constant. So I'll multiply the left side by 2 and I'll multiply the right side by 2. We're good. That 2 cancels with that, so we're left with this. And we're left over here with 270. And you can see by now, a small bit of rearranging. If I take this 9 and divide across now by 9, so now I'll go 24 plus 8d. And kind of by cross multiplication, I've brought this 9 down over here, so I have 270 over 9. So 270 divided by 9 should give me 30. And now I can say 8d is equal to 30 minus 24, meaning 8d is going to be equal to 6, meaning d is going to be equal to 6 over 8, which is, simplifies to 3 over 4. So I know that d is equal to 3 over 4. So that's the first part done. I always like to put a little red box around the answer. So that's part 1. What does part 2 ask us to do? Well, part 2 says the first, 9th and nth terms of this arithmetic sequence for are the first 3 terms of a geometric sequence, which you need to find r. So that means that the first term, which we got, was 12. We can figure out the 9th term, and some other term make the first 3 terms of some geometric sequence. So it can be a little confusing. They're talking about an arithmetic sequence in part 1, but they're saying if you take some of those terms from the arithmetic sequence, you can make a geometric sequence. And they're specifically talking about the first, 9th and nth terms. So if we look at geometric sequences, we can see we can find any term in a geometric sequence using this formula here. So what's that formula? So that's Tn is equal to a times r to the n minus 1, where a is the first term. Now it says they both have the same first term, so we again know that a is equal to 12. But what about r? Well, it says the first and 9th terms are the first 2 terms of the geometric sequence. Let's get the 9th term of the arithmetic sequence. So we want T9 for part 1, if you like. Right, so what's that say? That's using Tn is equal to a plus n minus 1d. So that's T9. Now, I figured out in the first part, I knew that a was 12. I know I'm looking for the 9th term. But what I had figured out was d was equal to 3/4 for the first part. So I can put 3/4 in here. So that means T9 is equal to 12 plus 8 times 3 over 4, which is equal to 12, and that's going to give me 6. 12 plus 6, which is equal to 18. So the 9th term from the first part should be 18, and the first term from the first part is also 12, which we share the 2 first terms. So therefore our geometric sequence looks something like this. It looks 12, and then 18, and then some n, which we don't know. How do you get the ratio for a geometric sequence? Well, the ratio is the difference. What do we multiply 12 by to get 18? Now, the notation you'll see in your book is something like this. Tn over Tn minus 1 is equal to the ratio. That means some term, Tn, over the term before it is the ratio. We know term 1 and term 2. Yeah? So, let's do this. Let's use term 2, which is 18, and the term before it, which is 12. If we look, that both simplifies to 3 over 2, if you like. 6 goes into both of those terms. So we know r now to be 3 over 2. So that part's done. What about the next term? Well, to go from T2 to the next term, we just multiply by the ratio. And essentially we're looking for T3 here. So what is T3? Well, we can just multiply 18 by 3 over 2 simply, and that will give it to us. Or we can just be real official and use the formula. I probably just would multiply term 2 by the ratio. But just as a good example for other questions, let's say we're looking for term 3. Term 3 is equal to what? Well, this is the formula we're using. So what's A? First term is 12. What's R? It's our new ratio. It's 3 over 2. N minus 1, but of course that's going to be, our N is 3 now. So that gives us 12 times 3 over 2 squared, because 3 minus 1 is 2. That gives us 12. Square in a fraction, square the top and square the bottom. 12 times 9 over 4. 4 will cancel with the 12. You can 3 times, do it on your calculator if you like. You're going to get 3 times 9, which is going to be 27. So the term n is 27, and I think that's the other part they asked us to find the value of n. So we have the common ratio r, and we also have n. So on to the last part. It gives us this fancy looking triangle, and it says the following. It says you need to find the perimeter in terms of L, but it does actually say that the 3 sides, it says, of this are consecutive terms of an arithmetic sequence. Now you can kind of see from the triangle that 3L is the longest side. So a small bit of thinking on this. What's the next longest side? Well, you've seen your diagram. It doesn't actually matter what order you're going, but from the diagram this looks to be the next longest side, and this is the side down again. If they're consecutive, that means the difference as you go up is constant. So the difference between this side and this side is the same as the difference between this side and this side. So they get bigger, but some common difference because it's an arithmetic sequence. So what we'll do is this. We'll call this next longest side 3L minus some D difference. And we'll call this side 3L minus 2D, or we've subtracted the difference twice to go back. So now what we would have is this. We would have our arithmetic sequence would look like this. The smallest term being 3L minus 2D. The next term being 3L minus a D. And the next term being 3L. Now if you look at this, if you add D to this term, you get this term. If you add D to this term, you get this term. So you need to be confident about that first. That's term 1, term 2, term 3. Now we need to find the perimeter just in terms of L. So I'm going to have to make an equation in L's and D's here for a minute. The only equation I can make, knowing what we know here and not knowing these two angles, is a cosine rule where I include everything. So the cosine rule is this. It says that we have, I'll write this down here. So you may wonder why am I using the cosine rule, but we have there's a small hint for cosine rule. When you're given an angle with its opposite side and nothing else, and you're trying to find information about a triangle, it normally looks at the cosine rule. But I'll explain that in another video at another time. So using the cosine rule, that is in your logbook, a squared is equal to b squared plus c squared minus 2bc cos a. Now, A being the angle, big A, and little a being the opposite side to that angle. So that means if we're going to pick A to be 120 degrees, 3L has to be little a, and B and C don't matter here, we can in any order. So doing that, little a is going to be 3L. Then B, let's pick this one, And then C side, which is 3L minus 2D squared minus 2 by B, which we picked what, 3L minus D times C, which is 3L minus 2D, and cos of 120, I'll squeeze it in there. So that's 120 degrees. Okay, sorry about that. Multiply some of these out. The first one's going to be 9L squared, that's 3 squared and the L squared. Multiplying this out, we're going to get 9L squared. Looks to be minus 6LD, and then plus D squared. 9L squared again. And then we're going to multiply two of these, minus 6, so it's going to be minus 12LD, and that's plus 4 and D squared, and then minus all that stuff there. So I don't want to go too much into all this, but I might just write this down like this, if you have a bit more space than I do. The cos of 120, maybe squeeze it in. Now, after a little bit of manipulation here and tidying things up, what you're going to get is here. You're going to get 0. We're going to bring this guy over here, and we're going to get 0 equal to... Now, I'm going to simplify it down, and you're just going to have to practice this and get down to here, but you should get down to something like this. 27L squared, and then minus 9L squared, minus 27LD, and plus 7D squared. It definitely is a bit messy, it's a bit tricky. What do I have? I have 2L squared, so I can actually go on a little bit here. So that's 18L squared, and that's minus a 27LD plus 7D squared. So I have this funny looking quadratic equation, which I'm going to have to work out. And what I'm trying to solve for is actually D. So I'm going to actually have to pick D as my X, if you like. So I might rearrange it, because I'm trying to solve for D here in terms of L, right? Because it wants our answer in terms of L. So let's rearrange this a little bit, pretending D is my X in a regular quadratic. And let's go like this, 7D squared. Let's put the next X term. So remember, we're dealing with kind of D as our X. The X stuff in the middle. It's minus 27LD. And then this stuff at the end, plus 18L squared. Now, you can solve this by minus B. And in the minus B, with the coefficient of our x squared, which is now d squared, for as a side note over here, our a for our minus b will be 7. Our b, now remember, our d is x, so we have to include minus 27 and the L, minus 27L, and our c being all the stuff at the end. So it's a bit of work, alright. So if you want to do out that minus b, just to save time, I won't. You should get two answers here. You'll get a value for d of 3L, or you'll get a value for d as 6 over 7L. So a little bit of work to that. Now we're not finished yet, we need to get the perimeter. But now that we know d can be one of these answers, let's look at the triangle. We're only going to use one of these. We cannot use 3L, and I'll tell you why. If the longest side is 3L, well then the next shortest side is 3L minus d. Now if we're saying d is going to be 3L, 3L minus itself is going to be 0. And you can't have a triangle with a side length of 0. And this will be actually negative, minus 3L. So we actually disregard this answer, we can't use it. We have to go with this one here. That means that the side that's 3L minus 2d is going to go to 3L minus 2 times, and now d is going to be 6 over 7L, and the other side being 3L minus d is going to go to 3L minus just 1, 6 over 7L. Okay, so let's tidy these up a little bit. That's 3L minus 12 over 7L, and this one here is going to be 3L minus regular 6 over 7L. So we actually have these two sides now just in terms of L. No D's, just L. So actually our three sides, looking at triangle, our perimeter is going to be 3L, which is the longest side. Now 3L minus D, we said that's 3L minus 6 over 7L, so that's plus 3L minus 6 over 7L, and plus the other side, which is 3L minus 2D, which is this stuff here, 3L minus 12 over 7L. And when you add all these things together, you should get 45 over 7L. And that's the answer. And that's question 2 done.